Good morning, Namaskar. At the outset, I on behalf of NTPC would like to thank the Indian Nuclear Business Platform for giving NTPC as the presenting NTPC as the next generation utility. The topic that we've been given to showcase is NTPC's role and vision for the Indian nuclear sector. Well, we at NTPC believe that the sector is very, very critical for NTPC because it appears as a natural transition for NTPC to shift away from a predominant thermal base to a nuclear base load company. And also NTPC is also most pivotal for this sector if the sector has to really accelerate in terms of capacity addition. NTPC, as most of you would know, is India's largest energy conglomerate, which is accounting for 20% of the installed capacity in the country and 25% of the generation capacity in the country. We have a huge fan base across the country and we are a 76 gigawatt plus company, predominantly coal-based, and we are also into gas, fuels, liquid fuels, hydro, solar, offshore wind, small hydro, PSPs, hydrogen, and many more. Apart from the 76 gigawatt of installed capacity, we have our 21 gigawatt of capacity under construction in the country, which is predominantly again coal. And you can see from the pie chart that the transition has started to happen away from thermal. When we talk about building capacities for nuclear, and one thing that comes to mind is the financial strength of the company because of the huge capex involved and of course the long gestation period. NTPC has steadily grown over the last many years, whereas as of today the net worth is over 1,70,000 crores. The revenue has constantly grown over the years. Last year it stood at 1,80,000 crores. The profit after tax for last year was 21,000 crores. So as you would see, financially NTPC has the might, the strength to take on the nuclear sector in the country. NTPC has the parent company has over 30 companies under various subsidiaries and joint ventures. So as we say, it's a huge conglomerate and we are almost into all sectors of energy and power production. Now, talking about the energy transitions, we've already stepped on very aggressively onto the road of energy transition. The capacity for nuclear has already been identified in the corporate plan at NTPC at 2 gigawatt by 2032, and we are well on that way because we have already received award from the Government of India for putting up Mahi Banswara Atomic Power Project, which is a 4 into 700 megawatt capacity, and we plan to commission 3 of these units by 2031. So we'll be, right now we are on our way to achieve that 2 gigawatt of capacity, nuclear capacity by 2032. Also, the transition is 60 gigawatt of renewable capacity is to be added by 2032, out of which I'll just, So we've already commissioned 4 gigawatts of renewable capacity in the country. Around 11 gigawatt is under implementation, and we have around 26 gigawatt, over 26 gigawatt, which is under pipeline. So again, we are well on our steadway fast approach to achieve the 60 gigawatt by 2032. Now, talking about diversification. So NTPC is also into coal mining, which was a part of our backward integration because we wanted to not be dependent on anyone for our own coal stations. Then we are into renewables, we are into power trading, we are into waste to energy, waste to charcoal, we are into consultancy services, and we have an exhibition pavilion outside which showcase our capacities across the globe as well, particularly in terms of consultancy ventures. We are into international business, carbon capture and byproducts, EV transport, green hydrogen, and of course now nuclear. When I talk about some of the hydrogen initiatives, and I'm telling you this because we want to showcase that NTPC is a very technologically adaptable company. When it comes to adopting any technology, we have done that, we've been there, we've done that. So there's a hydrogen blending station. We are at one of our gas stations at Kawas. The hydrogen vehicle buses are already on the run at Leh and Delhi. There is a green hydrogen hub which is being developed at Puri Madaka. There is a huge tie-up for electrolyzers across the country. Then there are pump storage capacities which are being developed across all the states in India. Then of course there is an MOU which to demonstrate the feasibility of hydrogen co-firing in the gas turbines. And of course there is a mega green ammonia project which is 1000 TPD at Khavan. Some of the other key initiatives that we have taken is the municipal solid waste to charcoal. We have adopted the air-cooled condenser. We have the world's largest air-cooled condenser installed at our North Kanpura facility. And in our future tenders, in some around 10 units of 800 megawatt, we are coming up with air-cooled condensers, which will take away the water consumption completely away. And just to demonstrate that we are as much focused on air and water as on any other thing. We have electric bus services, we have farm-to-fuel and bamboo-based biorefinery as well. Over the years, NTPC has steadily grown from having its first thermal station commissioned in 1982 at the efficiency of 38%, 36% rather. We have come down to now 42% with our ultra supercritical units. We are also under implementation, under development of advanced ultra supercritical, where we will have temperatures in the range of 700 degrees centigrade and efficiencies of 46%. So every 1% increase in efficiency will lead to CO2 removal of 2.5%. So again, this is a statement to show that we have grown over the years. We have grown in terms of efficiency improvement. We have grown in terms of heat rate improvement. And whether it is thermal stations, we are fully prepared, fully adept at adopting any technology, whether it is PHWR, PWR, or SMRs in the country. Now, the role for nuclear. So, based on a very simple calculation, if you try and understand the data which is available from the World Energy Outlook, the energy projections for the country by 2050 would be somewhere in the range of 6,500 billion units. Now, if you take up the MNRE data and you assume that you install all of the capacities for renewable in the country, whether it is solar, wind, and you assume a capacity utilization factor of 30%, even then you would land up with 4,600 billion units. And by 2050, the thermal stations at the current rate, and assuming you have renovation and modernization in the thermal stations for 2 consecutive lives, but eventually thermal stations are going to die out, so you will still have capacity thermal stations in the country at 2050 contributing to 1,500 billion units. So there is still a shortfall of 460 billion units in the country, which is assumably to be borne by nuclear. And NTPC is, fully prepared for this. So as I said, we have already adopted the multi-stream approach. We have already have a joint venture with Nuclear Power Corporation of India Limited for setting up pressurized heavy water reactors in the country, which is a technology indigenous to NPCIL. We have already received the transfer of one project from NPCIL to the joint venture company. It is a 2.8 gigawatt project, and it is well on its way of implementation jointly by NTPC and NPCIL. We are also exploring various states for taking up sites for building large capacity pressurized water reactors from one of the OEMs across the globe. We already have Russian reactors running in the country successfully, demonstrated by NPCIL. We have also set up a subsidiary company. NTPC has set up one more subsidiary company now under nuclear, 100% owned, wholly owned subsidiary, which will be foraying into the pressurized water reactors and the SMRs in the country. So as I said, this again reiterates the point that NTPC's management, the vision of the chairman is fully aligned to developing and going full throttle in nuclear. So this is some of the details of the Mahi Baswara project that we have recently been given the responsibility, which the project director is also from NTPC, and the charge has already been assumed jointly by NPCIL and NTPC. I do want to conclude my presentation with a vision for SMR as well, because SMR is now it's actually a small modular reactor, but it's actually the big thing now. So we do have a vision for SMR development as well. We want to adopt both the approaches, wherein we want to have development of indigenous technology with the technology providers in the country like BARC, where we can develop the technology indigenously. We have a vision for that as well. And we also want to adopt technology from foreign collaborators, from foreign OEMs who are ready, who have a technological readiness level somewhere in the maturity range, and we can have a technology transfer agreement. We can have Make in India concepts for that. And so again, to demonstrate that we are ready for SMR adoption as well. I thank you all, and that concludes my presentation. Thank you so much.
Hello everyone, my name is Jayhee Suhr, and I'm a manager at the Korea Nuclear Association for International Cooperation. It's an honor to be here in India to talk about the development of the Korean nuclear power industry and its export performance with all of you here today. So my presentation, I'll start by discussing the development history and its current status of the Korean nuclear power industry. Following that, I'll highlight the strengths of the Korean nuclear industry, sharing our experiences and achievements in the global market. Finally, I'll wrap up my presentation with the introduction of our organization, KNA. So, over 70 years ago, South Korea was among the poorest nations in the world, devastated by the impacts of the Japanese occupation and the Korean War. The country was left in ruins, struggling to rebuild from the ashes. So to illustrate this, here we see a photo of Gwanghwamun, the main and largest gate to the Gyeongbok Palace, the royal palace of the Joseon dynasty. And Gwanghwamun holds historical significance, and during the Korean War, it was completely destroyed, as you can see in this image. However, what was complete piles of ruins has now transformed into something like this. So 70 years later, the Gwanghwamun Square has become the epicenter of business and culture, and this remarkable transformation would not have been possible without a stable and abundant source of electricity. And South Korea achieved this through systematic development of the nuclear industry with a full government support. So after the Korean War, Korea urgently needed a reliable source of electricity to support both economic growth and energy security. So in 1959, we introduced nuclear technology with the construction of our first nuclear reactor on a turnkey basis. And 60 years later, Korea not only successfully implemented commercially viable reactors, but also achieved technological self-sufficiency. And with one of the largest nuclear fleets in the world, Korea is now at the forefront of supplying economically and technologically competitive nuclear reactors worldwide. Okay, so now let's delve into how the Korean nuclear power industry has developed starting from the 1950s. So South Korea officially launched its national nuclear program in the 1950s. We joined the IAEA as a member state, enacted National Atomic Act, and started building Trigon Mark II, the first research reactor in the country. And then in the 60s and 70s, our first commercial reactor, Korea Unit 1, was constructed and began commercial operation. And then later on in the 80s, many more reactors were built, leading to technological advancement. Then in the 90s, Korea developed the first localized nuclear power plant, OPR. It achieved technology self-sufficiency based on the accumulated expertise from both domestic and international sources. And this marked the start of a new era where Korea led its own nuclear projects. And then in the 2000s, Korea developed the APR 1400, a next-generation Korean reactor with improved safety and economic efficiency. And in 2009, Korea won a project to construct 4 APR 1400 reactors in the UAE, known as the Baraka Nuclear Power Plant Project. And currently, we're also working towards entering the global SMR market by 2030, and this includes the development of the ISMR. And this timeline here shows you how Korea has achieved localization and technology independence. Since the introduction of nuclear power plants in the 70s, when foreign contractors led projects through the turnkey method, Korea has progressively built its technological foundation. And in the 80s, joint projects and technology transfers enabled greater involvement from the Korean companies. And in the 1990s, repeated construction and standardization efforts were made, with Korean companies taking roles as prime contractors. And as a result, Korea began developing its own nuclear reactor models. And then in 2012, under the government policy known as New Tech 2012, Korea achieved full technology self-reliance. And this was accomplished by securing key nuclear technologies and reaching 100% self-sufficiency level. And currently, Korea has 26 reactors in operation and 2 under construction. And internationally, we're also operating 4 reactors at the Boracay site in the UAE. Nuclear power is a significant part of our energy mix as it accounts for 17% of the installed capacity and contributes 30% of electricity generation. Okay, now that we have learned about how the Korean nuclear industry has developed, I would like to discuss how we are expanding into the global market. So this is the overall structure of the Korean nuclear industry. You may also refer to it as the Team Korea. So at the top, we have the Ministry of Trade, Industry and Energy, which functions as the control tower for nuclear power plant exports. And the main contractor, depending on the nature of the project, it'll be either KEPCO or KHNP. And we have KEPCO ENC, which is in charge of design and engineering, KEPCO NF, nuclear fuel fabrication, KEPCO KPS, maintenance and operation. And we also have Doosan Enerbility, which specializes in nuclear steam supply system. And many more conglomerates and SMEs are involved in the construction, installation, and major equipment sectors. And by continuously undertaking nuclear power plant projects, Team Korea has maintained its competitive edge in the global market. First of all, we have the ability to build plants on time and within budget. Since the 1980s, Korea has, on average, started the construction of 1 nuclear power plant per year. And this has allowed the country to develop the capability to complete projects on schedule based on accumulated experiences. Also, we have established a robust supply chain with all the items being supplied through domestic sources. Additionally, we have a reliable and proven technology. Our technology meets the latest regulatory requirements of the US NRC, IAEA, and EUR. And lastly, Korea continues to push for innovative technology development. In terms of research, the country is advancing a wide range of technologies, including nuclear fusion and ISMR, that have the potential to lead the world. So as I mentioned, Korea began its journey towards self-reliance in nuclear power technology with Kori Unit 1 in 1978. And over the past 40 years, Korea has successfully pursued this goal by steadily constructing nuclear power plants and continuously putting efforts into technology development. And through these efforts, Korea has successfully developed models such as the OPR 1000 and APR 1400 as shown in the bottom left of the slide. In the next slide, I'll briefly explain the key features of each reactor model. So first off, we have the OPR 1000. The OPR 1000 is a Korean standard nuclear reactor, and it is recognized as one of the safest 1,000 megawatt reactors globally. It has optimized economic viability and safety by addressing issues found in previous designs. Also, we have APR 1400. The APR 1400 is an enhanced version of the OPR 1000, and the power generation capacity increased from 1,000 to 1,400 megawatts, and the operational lifespan extended from 40 to 60 years. And then in 2017, the EU APR, a modified version of APR 1400 for export to Europe, received EUR certification, and in 2019, it obtained DC from the US NRC. Also, we have APR Plus, which is a 100% domestically developed reactor that has cleared all barriers to export. All the previously mentioned reactors are pressurized light water reactors, but to diversify reactor types, South Korea has also introduced a pressurized heavy water reactor in partnership with Canada's AECL. So in AECL's CANDU type reactors were applied to Warsaw Units 1 through 4. So KEPCO ENC has gained design technology and operational experience in heavy water reactors as well. So now that we have learned about the strengths of the Korean nuclear technology, let me share some of our experiences in the global market. The KEDO project was initiated in 1993 and was established in response to the escalating crisis on the Korean Peninsula following North Korea's declaration of withdrawal from the NPT. The purpose of KEDO was to support global non-proliferation efforts and promote peace and stability on the Korean Peninsula by carrying out energy projects in North Korea in accordance with the Geneva Agreement. So KEDO's main tasks included constructing 2 light water reactors in North Korea, as well as supplying heavy oil. So the site was located in Sinpo City in Hamgyong Province, which is located in the middle of the east coast of North Korea. But due to the controversy surrounding North Korea's highly enriched uranium program that emerged in the fall of 2002, KEDO decided to halt heavy oil supplies to North Korea. And unfortunately, in 2005, KEDO effectively discontinued its operations. And finally, in 2006, KEDO and KEPCO contract was terminated with a 34% progress rate. Although the project was terminated with only 34% of the progress completed, it was a valuable experience for the Korean nuclear industry, as it was our first time building nuclear power plants outside the border, and it played a crucial role in laying the groundwork for Korea to win the UAE bid. So in 2009, the Emirates Nuclear Energy Cooperation in the UAE selected Korea's APR 1400 nuclear reactor, and the last unit of the 4 reactors started commercial operation in September this year, and the reactors are now producing about 25% of the UAE's electricity needs. The Boracay nuclear power plant is the first nuclear reactors constructed by South Korea and the first reactors in the Middle East. So it was a very meaningful project for both countries, and it established South Korea's presence in the global nuclear sector and reflects the nation's high standards in nuclear technology. Also, Jordan's first reactor was built with the South Korean technology. Boracay nuclear power plant was Korea's first export of commercial nuclear reactor, while Jordan Research and Training Reactor was the first reactor ever exported by South Korea. 50 years ago, South Korea imported its first research reactor from the United States, and then 50 years later, in 2009, South Korea was selected as the preferred bidder for Jordan's research reactor, and in the following year, the final contract was signed. And here are some of our recent achievements in the global market. In July of this year, KHNP was selected as the preferred bidder to build nuclear power units in the Czech Republic, and the final contract is expected to be signed in March next year. And in 2020, Rosatom selected KHNP for the Turbine Islands construction at the Eldaba NPP in Egypt. And additionally, KHNP won a project for a tritium removal plant in Romania in 2023. And I hope we could also cooperate with the Indian nuclear industry in the future so that both India and South Korea could make greater achievements in the near future. Let me just briefly cover the SMR development. There are currently over 80 SMR models under development globally, and South Korea is definitely one of the players. In fact, South Korea began developing an SMR design called SMART back in 1997. SMART was developed as an export-oriented reactor targeting the small-scale power generation and seawater desalination markets. And now we're focusing on developing innovative SMR, also known as the ISMR. It is being developed with a goal of completing the standard design by 2025 and obtaining standard design approval in 2028. And the difference between the ISMR and SMART lies in the further simplification of systems and the enhanced emphasis on modularization concepts. And many companies, including KHNP and Doosan, are collaborating on the development of the ISMR. And tomorrow, speakers from both KHNP and Doosan are going to talk more about the SMR project in South Korea, so please stay tuned. Okay, last but not least, let me introduce the Korea Nuclear Association, to which I belong. The KNA was established to represent the Korean nuclear industry and to serve as a bridge for international cooperation. We are a non-profit organization founded in 2011 by the key nuclear players in Korea, such as KEPCO, KHNP, and Doosan. And there I said we have 58 member companies, but more companies have recently joined us, so we now have about 70 member companies from the domestic nuclear industry. And our main goal is to promote Team Korea and our member companies by boosting its brand image. We conduct many promotional activities, including advertising online and offline, and taking part in exhibitions. And we also act as a bridge to help connect domestic and overseas companies offering services like consulting, certification, marketing, and B2B meetings. All of this is aimed at improving the export competitiveness of nuclear power companies and helping them independently enter international markets. And we're also running a website called KNext. And KNext provides a directory service of Korean companies to overseas organizations and buyers. And all the information here is provided in English. And this is a screenshot of the web page. Once you click on the supplier directory, you can search for supplier information by category, such as mechanical and electrical. And you can also find detailed information like supplier contact details, product specifications, and quality certifications. So this is the end of my presentation. Thank you very much.
Streamed and why suddenly this, I think, conversation and chatter has, I think, quite a feverish pitch about, and so I think before inviting the panel members, I'll, I think, give my brief opening remarks on why, and I think Mr. Tyagi from NTPC talked about it briefly in his presentation, that in turn, India, of course, is wanting itself to become a developed nation by 2047. And there is a rule of thumb that there is a 1.25 or 1.5x multiplier for every percent growth of GDP. And that means if India is going to continue to grow at 7 to 8% nominal or real terms, GDP, we need a significant amount of energy for India to help achieve that GDP target by 2047. I think in the flyer itself there was this data that India would need something like 28,000 terawatts of power consumption by 2070, if I'm getting that right, and I think the renewable sources will help supply, if I'm remembering correctly, about 8,000 terawatt hours of data, which means that that sort of gap needs to be filled in. And simultaneously, India is also talking about being net zero by 2070. So we are looking at achievement of two goals simultaneously. One is fast-tracking India's GDP growth through required energy consumption, as well as making our GDP growth and energy production zero carbon. And I think while of course the renewable energy, which is solar, hydro, and various other, most popular have been solar, wind, recently. But because of this gap that has been realized, and because of the fast growth, and because of some distinct advantages of nuclear over these other renewable sources, namely wind and solar, one, of course, the nuclear provides a consistent and stable base load, and for a dense country like India, the space requirement for a nuclear projects are far lower. So on both counts, certainly nuclear kind of scores a march over solar and wind. And the other factor, of course, is that there are other demerits also, of course, with regard to high upfront cost requirement. There are perceptions about safety, fuel disposal, which have kind of, I think, been the cause for really nuclear not having taken off earlier as it should have been. Because even if you were to look at both in India or even globally, there have not been known incidents, at least in India, there have been instances of fuel leakage leakages from Tarapur, Bagh project, but there have been no reported instances of loss of life or I think radiation leakage in the neighboring areas. And even globally, there have been just two big incidents. One is the Daiichi one in Fukushima in Japan, and the other was Chernobyl. So clearly, I think the public perception is really for the government and regulatory authorities to manage, and maybe they're coming around to that view that maybe it was kind of overplayed given what we need from it. And the other aspect is, of course, the variability factor for solar and wind. And even though the initial investments may be smaller, I think with the need for they having storage and backup requirements, the overall cost for a solar or wind project or other sort of renewable projects do end up from a life cycle perspective, do end up becoming maybe equivalent or even higher. And nuclear plants have larger lifespans, low operational costs. Of course, the initial costs are high, and maybe the return on investment, given the long life of nuclear, meeting, of course, the public safety and perception requirements might be comparable or even better. The only, of course, challenge for India growth is really, I think, the fuel supply. We are still dependent on fuel and technology to a large extent, although there is conversation around whether thorium can be used instead of uranium, and I think we will need to wait and see whether we develop our indigenous capability on it. And but I think on the flip side, on the net zero emission, I think even though we have nuclear as 3% of the total energy basket, I think it's contributed to something like 41 million tons of CO2 emission saving. And there is, I think, data which talks about that it might lead to, when we reach whatever 9% by 2047, it might contribute to saving of something like 6,000 to 20,000 million tons of CO2 saving. So on an overall sort of a comparative basis, there is very strong and clear case for nuclear to form a very important and a larger component of the energy transition, the energy basket in India, and certainly to go up from the current 3%. And from, I think India is perhaps the 10th largest in terms of contribution of nuclear in the overall energy. For India's, I think, number to go up, and I think even it seems to be happening. At least India is probably the third largest in terms of nuclear projects under construction. I think, of course, US and China, as currently the case, are ahead of us. But hopefully things will change, and I think we will touch upon on some of these aspects that I've talked about in my opening remarks with the panel members who will be discussing some of these issues. So may I please invite Mr. R. Sharan, who is the Director of Projects, Nuclear Power Corporation of India, Mr. Ankan Mitra, who is the Chief President, Executive-Mumbai, Tata Steel, and Professor R. Srikanth, who is the Professor and Dean, National Institute of Advanced Studies, to join me at the dais, please. Thank you. Good morning to all of you. It's a pleasure to share the dais with all of you here. Before start of the panel, may I request each one of you maybe talk in a minute about yourself, introduce yourself to the audience. I'm sure you need no introduction, but it will help in kind of setting the tone for the discussion.
Basically started my career in coal mining, and I lived reactor in US. I'm now a big fan of nuclear, and I really hope really ramps up its nuclear, and so I'm very glad to see a lot of industry participants here, because without private industry participation, India will be able to. Thank you.
Yeah, I'm R. Sharan. So I have been driving this nuclear program in this year, and I'm hopeful that this program will accelerate. And we know that we have got 3 stages in the nuclear power program. So first stage, NPCI has progressed well, and on second stage also program is maturing, and in between there is requirement of net zero achievement through nuclear source. So we have got many way of working to achieve this target. So with Government of India, we have chalked out you can say that firm program, and the program is like this, that we will be constructing large reactors, as well as we will have Bharat small reactor and SMR. So all these things have to mature, and Mr. Srikanth has already told that without industry participation, it's not possible. So I am very happy that from industry many people are here, and they will be participating in this program. And in a large manner, private company can also participate in the nuclear power program, and that will only be helpful to accelerate this net carbon zero our ambition. So I am thankful to Mr. Saxena. He has rightly spoken about so many things, but one thing is important: utilization of thorium will be also very important in the program, because energy security will depend upon supply of fuel, and that should be from indigenous source. So thank you very much. We will have discussion.
Am I audible? Good morning, everyone. I am Ankan Mitra from Tata Steel. I work as the Chief Resident Executive in Mumbai, looking after corporate and regulatory affairs for the company in West and South. And by training, I am a mining engineer. I began my career in mining and shifted over to corporate affairs a decade back. I worked with NTPC extensively before moving to Tata Steel. And prior to speakers, I've spoken passionately about nuclear. I am absolutely new to nuclear. And my colleagues attended a session by NPCI a few months back and briefed me about the small and modular reactors that were on offer as captive power plants being envisioned for the hard-to-abate sectors like steel. And of course, there are concerns within the company about that, and I'm here to learn over the next 2 days and sort of get back to the company on how these concerns can be addressed. Thank you so much.
Tone for the audience to get to know the expertise and background of the speakers. The panelists, I think, on the dais really reflect the practical examples of, I think, the growth of the nuclear sector, as well as the likely direction the nuclear sector is expected to take, with, I think, particularly with Mr. Mitra's participation on the panel and the focus on involving the private sector. And of course, I think with NPCIL being on the panel and Mr. Sharan, I think, and with NPCIL really being the flag bearer of India's nuclear program, I think it's but natural that my first question goes to him. And of course, first, congratulations on, I think, first the RAP7 acquiring criticality. And that's really marks a very significant step in, I think, India's nuclear journey, and I think the critical role for nuclear in the clean energy basket. And of course, Nuclear Power Corporation of India has perhaps the greatest and the deepest experience with its presence in already projects in Andhra, Madhya Pradesh, and other parts of the country. And I think the plan that I have for the panel is that while a question will be addressed to a particular panelist, I would request the other panelists to feel free to contribute. I think if they think that they would like to comment or add to what a particular panelist may have already spoken on the question. And I think we are not really discussing maths here, we are discussing perspectives. So even though there might be an opposite view or an idea to what somebody might have expressed, as I think they say, the opposite of a good idea need not be a bad idea, it can be a good idea. So we are happy to discuss conflicting perspective on a topic. So and I'm sure with the wealth of experience and I think the knowledge that the panelists have, we are looking forward to a very interesting and enriching panel discussion. So Mr. Sharan, let me get to you. What do you think has been the reason for nuclear energy not having gone its due share and for it to suddenly be getting sort of the focus and limelight that it is getting? What do you think has been the reason in the past and what is the reason currently?
As you know that our Atomic Energy Act, we have to follow Atomic Energy Act in India and we have been following. So NPCI was earlier only authorized to do nuclear business in India. Of course, with the support of R&D from our Atomic Research Center. All these processes has taken time. As on date, design of 220 megawatt is mature. Design of 2 into 540 megawatt PHWR is mature. Design of 2 into 700 megawatt is mature. Actually, tomorrow I will show you in our slide how the maturity of design has taken place. And now we are able to run these reactors at very high capacity factor, more than 95%. So all this learning process was there, that's why it took time. And in between, as you know, that Fukushima accident also took place. And it brought many changes in design. So rigorous changes in improvement in design, its regulatory clearances, convincing regulators that whatever changes we have done, improvement we have done are now at par with the international standard, and no DSAP is possible in India. As you know that in Indian nuclear power program also, you have rightly said that there is no, you can say that incident or accident which has involved public. So that is a great achievement. So now India has matured in PHWR design, and at the same time in construction of pressurized water reactor, which we have collaborated with Russia, and we have got a large program to also collaborate with the European Union, French people, to have project in Jayhee, then with the Westinghouse to have project in various parts of our country. So all these things are maturing. But one thing is very sure that whatever power we will produce, that should be at economical price, and our public should be able to buy. So whatever delays are taking place in importing foreign reactor or even SMR, that will be guided by economic consideration. So that is the main focus now. Technology-wise, India is now totally mature. We are having, we have mastered PHWR, we have understood PWR, we have understood this boiling water reactor. We have got good technology base to face any situation. Now economics will play a role in the future to guide the future program.
Thank you, Mr. Sharan, for I think those opening remarks. And I think if I could pick up from one of the comments in your remarks, and I was talking to I think a visitor early in the morning, and I think he kind of had the same question. And if you're in the market, of course, ultimately the buyer decides whether your product is worth its value or not. And you touched upon the fact that the economics will decide the viability of BSR. And of course, the BSR significance is very critical because of, I think, its ability to be installed in areas where the traditional nuclear reactors or other power projects will not be installed. And of course, it's very material for players like Tata Steel and other in the aluminium and other mining industries. So, and the question that the visitor had made, that is the cost of a BSR reactor going to be competitive to the traditional sort of reactor or comparable to the other alternative sources of electricity or energy that are available? And what are your thoughts on that? And
See, Bharat small reactor is based on pressurized water reactor design, which is already matured in India, and this power plant based on that has been operating since last more than 35 years. So, bill of quantity is known to us, and its entire manufacturing is being done in India. So, it will be certainly economical. We have to only see that how fast we can construct, because as you know that nowadays we are constructing nuclear power plant with borrowed money also. So we have to pay for the cost of the financing. So financing cost will be lower if we are able to construct this CSR in less time. So we are targeting that in future, if we are able to construct in less than 4 years time, then cost of financing will be less than 10% of the total cost. So it will be certainly cheaper. Similar thing we want that SMR, which are being provided by various countries, its BOQ should be known to us, and it should be manufactured by Indian company. So it will be certainly cheaper. Design can be of anybody, but if BOQ is known, so critical component can be manufactured by the designer in any part of the world. But more than I think 80% of the component can be manufactured in India, and then only cost will come down. So this effort has to be taken into future.
Professor Srikanth, if I would come to you.
I think we have to understand that BSR is not a modular reactor. And as Mr. Sharan said, the greatest advantage of the BSR is that it is completely proven indigenous technology. So it's proved its safety over nearly 40 years. So there are great advantages in basically starting off the journey of private sector entry into nuclear power. So that way you're starting on a safe footing. So it's a good start. But what I would definitely say, working with many people on BSRs, the siting requirements of BSRs need to be revised. There are no siting requirements for BSR specifically today. So we are following the siting requirements which are there for normal reactors. And the problem with that is the normal reactors require an emergency planning zone of 16 kilometers today, which is equal to about 10 miles in US. Unless we dramatically reduce that, what I feel is the potential for BSRs is quite less. That is one. The second part, what I feel is that right now the full details, the budget had made that announcement, the full policy details are still not out, particularly on the Liability Act. So how the Liability Act is going to work, while the liability says it's on the Act says the operator is absolutely liable, but of course the concern, if I am the owner of a plant, or if I'm using 51% of the electricity coming from a BSR, tomorrow will there be any litigation? Because in India we have the concept of PIL, public interest litigation. Will there be problems that the owners are going to face with unlimited liability? Because the whole problem basically is the Act, the rules and the FAQs. There is a lot of contradiction between all of them. And I think DIE well realizes that the Act is an overreach. And DIE, that's why basically MEA has got this FAQs to basically allay the fears of many investors, not only foreign investors. But what I feel today is the problem is the Liability Act has become an impediment not only to foreign investors but also to Indian investors. And this is something that needs to be understood by everybody from industry in this room. And unless what I feel is the biggest problem that I see in India is solar and wind have huge lobbies. Battery has huge lobby. Nuclear has no lobby. And so therefore what is happening is there is no discussion in public fora. Right now what is happening is there are few op-eds that have come out which support nuclear, but all of them say one thing, that the Atomic Energy Act has to be amended. All of them say the Liability Act has to be amended. This is what the business media say today, and therefore what I feel is that it is time for the government to bite the bullet and say, yes, I am going to amend the Act. Let it be discussed in Parliament, let us see what happens. Passes or fails, that's another matter. But unless what I feel is in the long run, or not long run, short run, unless the Act, both these Acts and the corresponding rules, etc., are brought brought into harmony with what is the need of the country to reach net zero at this hour without compromising on our development aspiration, unless the government bites the bullet, takes it to Parliament and gets these amendments done. My fear basically is we will have more and more conferences like this, but probably, very less is going to happen on the ground.
Thank you, Professor Srikanth. I think you ended your comments with a classic statement that I can summarize as India disappoint both the optimists and the pessimists. So I think there is always a lot of conversation, and I think whether the progress translates into conversation is always a question mark. But it's interesting, you raise a very interesting point about the liability, and I think without getting into the technicality, you're right, I think, and as a lawyer, I wanted to add to what you said. I think government has tried to do sort of all the frills around, I think, to clarify in the form of these FAQs and coming up with clarifications and trying to allay the concerns of the foreign investors and the local investors. But I think the simplest fix which was there, and that perhaps is giving a concern to an investor, because from a very simplistic but a technical, it's the act which will always prevail, the language of the act which will always prevail over the FAQs. And I think that causes a concern in the mind of an investor, that is there some sort of a other plan behind really not doing the fix as it is required, as against issuing clarifications and FAQ. And you're right, I think if they're really serious about inviting private participation, they need to, and I'm not sure whether it despite, I think, stating it so obviously about the importance of nuclear, whether, and if that is the case, why should the amendment of the Act not be on the agenda if they really want to invite greater sort of capital and technical expertise from the private sector? So you are absolutely right, and I think couldn't agree more with you. If I could come to Mr. Mitra as one of the industry participants, and I think before getting into the BSR, the first question I would like to ask you, Mr. Mitra, of course, your sector and generally the mines and mineral industry is a very energy heavy, energy sort of usage, heavy on energy usage. And traditionally it was thermal power, which was really the mainstay for energy use, and of course now it's shifting to having captive renewable in the form of wind and solar. So how do you foresee, what role do you foresee for nuclear in terms of becoming energy usage for the production of the business or energy users in your business, and how does it kind of, does it integrate into with your other energy users? Would it, at some point, do you think it can replace it? How do you foresee on the industry side, the role of nuclear for your industry?
So I'll first give a very brief backdrop of the energy mix for the steel industry. The steel industry essentially consists of the integrated steel plants and the smaller players who make steel out of sponge iron or scrap. When you talk about the integrated steel plants, that constitutes around 45 to 50% of the current Indian production of around 140 million tons. Let's say 60 to 65 million tons comes from the integrated steel plants. And when we talk about the integrated steel plants, they are actually energy sufficient, because we rarely take energy from the grid, because we have a reducing agent called coke, which is the coking coal turned into coke, which reduces the iron oxide. And when it does so, when it is transformed from coking coal to coke, there is a lot of coke oven gas. When the reduction reaction takes place in the blast furnace, there is a lot of blast furnace gas. All these flue gases are very rich sources of fuel, which we use for generating thermal power. So the steel plant is currently running from power which is generated within the steel plant from the coke oven gas, from the blast furnace gas. There is pressure to energy. These gases, when they come out from our blast furnaces, we have top recovery turbines. When the coke is cooled through a process called CIDCO dry quenching, there is also energy generation from the waste heat. So all this is sufficient as far as the running of a steel plant is concerned. Going forward, when we transition from this to, let's say, scrap-based steel making as the Western world has done. And we see India also, let's say, 50 years down the line, when we have a running scrap industry and we start producing scrap-based steel only. That is the point of time when we see energy sources like nuclear will be kicking in a big way. Currently, for a plant, let's say a Tata Steel plant in Jamshedpur or a Tata Steel plant in Kalinganagar, we won't need a modular reactor or a BSR to be set up. There are concerns and there are siting requirements which sir has already mentioned. We can't have a 250-acre plot dedicated so that we at least maintain a 1 kilometer safety zone, which after the amendment of the acts can be possible. Current 16 kilometers, no way. But that thing can only come in when we transition to an economy where we produce steel only out of scrap.
So, Mr. Mitra, if I understood you correctly, are you saying that use of nuclear, therefore, for industrial processes is some time away, or is it that BSR is not really a viable option, but you're open to kind of, subject to, of course, grid permitting it, consumption of nuclear energy as a mix in the basket of energy that you consume?
As I told you, we have two types, integrated steel plant and the smaller ones. The smaller ones consume energy from the grid. And if the grid is able to give suitable amount of nuclear energy, then why not? We are open to that. If the grid matures to a status like, let's say, Korea, where you have 25% of the grid sourced from nuclear, then why not? People are open to it. I was talking from perspective of integrated steel makers.
Mr. Sharan, coming back to, of course, whatever are the effective, I think, the raw material or the key ingredient for having a nuclear plant running is, of course, the fuel and the technology. Has India progressed sufficiently for to start to reduce its dependence on fuel and technology? And would these two requirements become a constraint that will kind of slow down or torpedo India's grand plan to add nuclear to the desired component in its energy basket?
As you know that India has signed 123 agreement, and after signing that we do not find that any constraint with regard to uranium fuel will be concerned. Only thing is that we cannot proceed with the uranium fuel for a long time. We have to explore our thorium-based fuel. In that direction, India is working at present, how to explore this thorium-based fuel. So many design is available and we are working on that. So we are sure that fuel will not be a constraint in future. Just since I am in the panel, I would like to talk about this emergency preparedness zone. For BSR, we are trying our best to see that this is reduced to this boundary wall. It will not be beyond the campus. So that is being discussed how to do it. And I feel that SMR design also should be in that line, so that EPZ requirement should not go beyond, because I know his concern is right, let me say, or any industry will not like to go for a long distance for EPZ. So that has to be addressed. And regarding this, you talked about this CLND Act. So that is also has to be is being addressed by approaching insurance company, and we are trying to see that entire international insurance company will be also in the picture, so that the total basket of amount will be increased. So within the act, how we can extend the coverage, that we have to see and proceed. And one more thing is that is a question of debate, that why accident will take place. If we can prove that accident is not possible, if we can increase the quality surveillance to such an extent that with 100% guarantee we can say that there will not be any accident, then CLND Act has to be seen from that perspective also.
Thank you, Mr. Sharan. Of course, I think India, like I mentioned in my opening remarks, has had a very good track record on the safety. But I think it's more to do with, I think, just perception. And yes, I think there is no doubt that the safety needs to be given the potential risk that can follow to be the highest level. But I think so far as I think the legal and institutional framework is not changed, I'm not sure whether the insurance company will also be willing to honor the claim that is made in a situation where there is absence of regulatory clarity, and therefore I think certainly it will go a long way, like we were discussing. A change to the law would perhaps put an end to, I think, the discussion. And I think large investors, people with deep pockets, and particularly private investors. And I think maybe it's not been a concern so far because the nuclear sector has been largely state-owned. But I think if India has to invite private capital, I think to some extent, I don't think we need to give in to everything that is being asked, but certainly be sensitive to where there is a reasonable request, and I think try and draw a balance between India's needs and the private sector's need. Coming to Professor Srikanth, because if I'm correct, I think you also spent some time on thorium versus uranium. And how do you foresee, given that so far India has been traditionally dependent on uranium as the fuel for its nuclear energy, and now there is, of course I'm not an expert on this, but there is this talk or studies around thorium. It's possible to convert thorium into nuclear reactor and for energy generation. Where do you see taking off from where Mr. Sharan said? Would that become a challenge in India's ambitious plans around nuclear generation, or is there some realistic ideas or assessment around thorium becoming a viable use as fuel in nuclear power generation?
First of all, I want to say I am not an expert on thorium or uranium, but what I would like to say only one thing is that the narrative that is being spun out is that somehow imported technology, even if it is made in India, is an enemy of domestic technology. I think India is so big, our needs are so big. We are now having a peak demand of 250 gigawatt. It is the third largest electricity generator in the world, and 76% of our electricity is coming from coal today. And I just attended meetings of the government, which very clear, with another 80 gigawatt of thermal capacity being added, we are not going to peak in coal generation till 2040 at least. So now the question is, how are we going to reach 2070, net zero? If we go at this rate of business as usual, nothing will happen. So the problem what I feel is, there are two narratives. One narrative is, the Liability Act amendment will favor foreign investors. I think that narrative has to be killed. The Liability Act is actually detrimental to Indian investors. That is number one, that should be killed by industry itself. Because if industry doesn't participate in setting the narrative, it is activists who are going to set the narrative, and they are already setting the narrative. Number one. Number two basically is that somehow if you import, you are basically going to be, hostage. Now the question, you look at our oil. 90% of our food is basically getting imported. Does anybody say, no, our energy security is at threat? Nobody says that. Because today, the sources of crude oil are quite diversified. They are getting from Russia. We have proved that our refineries can refine any amount of, any variety of crudes. The technology, the flexibility that our refineries have demonstrated indicate. Same thing holds true for uranium. And more so, if you are able to take this, less than 5% low enriched uranium, the advantage what we see with SMRs or with light water reactors, for the matter is, if you are able to, not if you are, when you are able to set up a national reprocessing facility, the advantage what will happen is, the waste from the LWRs and the SMRs can be reprocessed and produce fuel for the PSWRs. Today, most of our 16 reactors, if I recall right, PSWRs are relying on imported uranium. Advantage of uranium obviously is its energy density. In a size of this small, I'm sure you can run reactors for maybe 2-3 years. So the problem is the right narrative is not there in the public, and it is high time industry which wants to get into private industry in particular, which wants to get into nuclear to actually decarbonize their operations, which is inevitable. They have to get into this spinning of the narrative, while thorium and the third stage program will have to be pursued by BRC and Bhavini, which is the special vehicle set up by the government. That is a must. That will happen, and that is going to happen. But in the meantime, we should also pursue this, because our needs are so huge and our needs are urgent. What I would say is, one particular thing I feel, I request the foreign manufacturers as well as the Indian manufacturers here, is that you need to have a leap of faith. That is, form a tie-up so that you can actually make in India. We have got the capacity to produce maybe for the entire world. We have enough people, enough skilled people. We have manufacturing facilities. We have a culture of high quality nuclear manufacturing. If somebody has got that leap of faith and you start making in India, not only for India, but also for the world, I think the day that somebody does that, I think basically the whole scenario will change. So I think that is what we require. All this talk about fuel, this, that, and all that are all peripheral. We have got a global trade. We have signed the 123 agreement. We got friendly relations with everybody in the world. So I am sure we'll be able to get fuel. We'll be able to develop our thorium-based reactors. All of this is possible. But industry has to get into the act and lobby the government, and somebody in the foreign players has to have faith with an Indian player to set up a manufacturing facility in India.
Thank you, Professor Srikanth. I think you made some very interesting points there, which I will try and pick up. One of them, of course, I think the market opportunity size is so big that I don't think there is really intra or inter-segment player competition. There is just too much available for everyone, and therefore I think nuclear cannibalizing on something else and something cannibalizing on something else certainly is a situation that is not likely to arise. And of course, like you mentioned about the peak power capacity, my sense is, without being a soothsayer, that we will have a shortfall in peak power capacity every year. And I think, like this year, the government had to scramble. They had talked about no further investment in thermal projects, and they realized there was a 11 gigawatt shortfall in the peak power capacity in summer, and they had to suddenly kind of tender out a couple of thermal power projects. And I think next year the peak power capacity is expected to be, I would think, to be about 350-400 gigawatt, and that will continue to increase. And therefore, I think the need is really to kind of overshoot on the assumption rather than undershoot, as has typically been the situation in India when planning different sort of assets. The other, I think you talked about is I think, given I think the India's macro, I don't think the fuel import bill perhaps will be as big a concern going forward as the oil import used to be a concern in the past, given I think the surplus on the current account that we are kind of been generating and will continue to generate going forward. We are doing $100 billion of from remittances and GCC and various others. And we've diversified, of course, our oil procurement also from to 56 countries in the basket, and therefore, and I think going forward with the energy transition that is happening, the importance of oil will continue to keep going down, and that posing as sort of a constraint on India's current account and macros. And likewise, I think for us, if we have to import, I think we have to just make sure we are richer. We just have to keep growing our GDP, and that will really offset the downside of really if import of nuclear fuel is required. And yes, I think you made a comment in your opening remark as well that, of course, lobby is not a good word in India, but certainly the industry needs to perhaps do, I think, management, knowledge management, or I think representation to both the governments and the end users to deal with the perception about, public perception about safety, radiation issues, leakage, as well as I think with the government to kind of change the law to have a more enabling regulatory and financing sort of infrastructure in order to make it, I think, attractive for private sector to participate. Because I think without that, while as much as I think government and I'm sure NPCIL has really shouldered disproportionate sort of burden so far, but I'm not sure that I can speak on their behalf, but I'm sure they would also welcome, I think, greater sort of private participation, and I think both players in the private sector and the government sector going shoulder to shoulder to kind of achieving the goals that India has set for itself. So Mr. Sharan, if I could come back to you, how do you, and maybe sorry if it's a provocative question, but do you think it's a sector where government should continue to have the monopoly on the ownership and operation? And if there was a reason for that to be the case in the past, do those reasons still continue to exist, or there has been a change in the ground realities now for the private sector to also be the owners and operators of not just the BSRs, but also large-scale nuclear projects?
See, slowly we are opening. If you see, as on that Act doesn't provide private sector participation, but we have understood that, we have gone through the Act deeply, and we have found a solution that through BSR initiative, private sector participation can be encouraged. So they will be learning through this process, and by the time they will learn, government is also keen to change the Act. Once the Act changes, there will be huge private participation. And as you know that we have already signed JV with NTPC, which is a government company. So they will also push this nuclear power program. So there is now, you can say that NPCIL on its own, NPCIL with NTPC will accelerate the nuclear power program, and now under the BSR model, private sector they will accelerate the program. Only thing is that ownership, as on that, as per Act, it has to be with NPCIL. Once the safety concerns are addressed, when the government gets confidence in other sector that they can also implement nuclear projects and they can run the plant nicely, Act will be changed and all private participation will be possible.
Okay, Mr. Sharan, sorry for a follow-through on your remarks, but what I wanted to get to is there still not confidence in the private sector because of, I think you mentioned that if there is comfort on the safety aspect, and then maybe private sector will be allowed, but is there still not comfort because NTPC is still a PSU, BHEL is still a PSU, and so is NPCIL, which is 100% owned by the government. Is there not confidence in the private sector to deal with the safety or other aspects that come with owning and operating the nuclear power plant, and therefore that will delay the participation of a private sector as 100% owners? Or if not 100% owners, can they not be at least joint venture partners with, let's say, NPCIL? And they basically develop the capability and expertise, and then in a graded manner the government allows for 100% ownership and operatorship of private sector. Because to add to it, of course, globally there have been large owners and operators, and keeping the liability bill aside for the moment, can they not come and own and operate projects in India?
Yeah, you are right, but this requires a learning process. Actually, NTPC also, once they have joined nuclear sector, they have to undergo a learning process. Similarly, this private sector, they have to undergo this learning process under BSR initiative, and then only government will get confidence. So this is a question of getting confidence. Of course, NTPC is superb in their business. Many private sectors are superb in their business. They are running the plant, running the plant safely. But as far as nuclear is concerned, there is public perception that even a small incident can create a havoc. And that drives, you can say that psychological you can say the way of thinking, that we have to be very, very careful. So this can be established only by learning process, and I think 4 or 5 years time is required to establish that they are now fully mature. And I think, as you know, that changing of act is also not so easy. So it will also take some time. So many processes are involved. So by the time act will change, learning process will be also completed, and in a very smooth manner, transition to private sector will be possible. But on SMR front, I would like to tell you, if proven design is available, they can have regulatory clearance from their country, and there can be a different way of working or regulatory clearance for SMR, single window clearance, all those things may be possible. So through SMR route, where fueling requirements are different, in a 4-year or 5-year time, even after 7 years, we may have to refuel. They are guaranteeing that design will be, you can say that fail-safe, there will be passive system. So many improvements are possible. So through that design, it can be proved that safety concerns are almost negligible, and then it can be with joint venture with the private sector as far as SMR is concerned in near future, you can say.
Thank you, Mr. Sharan. If I could come back to you, Mr. Mitra, of course, I'm not sure whether you would know what Tata Group's plans are going to be, whether they'll ever be owners and operators, but if I could just pick your brains in terms of what are your thoughts, I think taking off from Mr. Sharan's comments, in terms of, do you think that if in other sectors, they've been opened up for private sector participation, and of course, taking into account the fact of public perception and very high need for high standards of safety and likely damage, is there any reason for private sector to not be part of? Do you think the sector would benefit from private sector participation? Keeping aside, yes, we need to amend the act and do all the regulatory framework, but keeping all those things aside, do you think the time is ripe for private sector to be allowed to enter the nuclear energy generation, owner and operatorship?
Absolutely, because there's nothing that should stop private sector participation, let alone generation and setting up nuclear-based power plants. Even if the value chain, let's say uranium mining, why can't a private sector entity do uranium mining? That is also absolutely not allowed in India. Even beach sand is not allowed to be mined because it contains some amount of monazite. Whatever anything the word atomic gets in is absolutely out of the domain of the private sector. So that mindset has to change. That mindset has to totally change, and at least uranium mining has been practiced in India for so long. It is safe. So it should be allowed, private sector participation should be allowed in the entire nuclear value chain. And of course, bigger groups will come in, and as Professor Srikanth has mentioned, it is up to the industry to change the narrative, and the industry will only change the narrative when it is allowed to participate.
I think pivoting to a different aspect, I think on safety, and I think which is linked to public perception. So Mr. Mitra, there is of course a very strong sort of sentiment is not in the backyard, and you talked about in response to the first question that the limits for keeping a buffer zone are very high. So even with the BSR program, are the current regulatory proposals good enough for managing the safety aspect? Because one of the reasons for, I think, delays or for not timely completion of broadly the infrastructure projects in India, and particularly the nuclear projects, is the land acquisition. There is heightened sensitivity around, I think, people not wanting to have a nuclear project in their vicinity. So how do you think aspects of safety and public perceptions can be managed for BSR program to be successful?
First and foremost, the government needs to do an image building as far as nuclear power is concerned. It needs to communicate to the mass public that this is something which is there in India for more than 50 years. And it is absolutely safe. People are residing in the vicinity of nuclear power plants, and that message has been subdued in India. So when the government goes for building a power plant today, it faces a lot of resistance. Why? Because they don't know that Tarapur existed for the last 50 years. So that messaging has to be built up. And when you talk about private sector end user industries adopting SMR or BSR, whatever you wish to call the small reactors, you have to build those things in the regulation itself. Suppose, let's say a secondary steel plant wants to have a BSR. Will it be required for it to amend its EC and say that as part of this we are putting a plant and we have to go for a public hearing and we'll get all the backlash? That sort of facilitation in the scheme of things has to be brought in. As Sir already mentioned, you have PIL. Suppose we decide to go in for a BSR and we face a PIL, how are we going to face that?
No, even short of a PIL, I can tell you from my experience, I think even for renewable projects, in a particular state in India, there is a right of way allowed pursuant to the Act for construction of a renewable project. And even in that situation, the landowners have gone and filed a case in the local court, and a stay has been granted by the court ex parte. And then you keep moving heaven and earth to kind of get that stay vacated for the next 2 years, and then you have to go move APTEL, saying that, look, please increase the COD because there is this, so PIL is, of course, nuclear is really in a different beast altogether, but even something as small as acquiring a right of way leads to litigation in India. And you're right, I think if really, I think government is serious about getting activity going in the manner that they want to, there has to be sort of a package deal in terms of in consultation with the industry players and particularly private sector, and maybe leveraging the expertise of NPCIL on what have been the challenges and how to fix it to make it more attractive. Because I don't think we can function without energy. One, it will put paid to our plans to grow. And second, I think if there's no energy, we'll not be able to use our mobile phones. Most important aspect of our life these days. So, coming back to you, Mr. Sharan, I think, and we're probably closing the panel. From this, picking off from this concept of private sector, and I think you think that the private sector participation is a while away, and I think they need to learn, and maybe rightfully so. But from your experience or NPCIL's experience, what have been the biggest challenges in terms of implementing, developing, operating of nuclear projects in India, which I think a private sector could benefit of as in terms of learning, so that as we have private sector players here, so that they are familiar with it, and I think they can take that away as a message, I think, which they need to be familiar with and work around with, and maybe talk to the government about for liberalization in order to increase in private sector participation in India.
So, in case of nuclear field, there is no shortcut. So our regulators establishes this practice that there is no shortcut allowed. So even to take example of land acquisition, selection of land, site selection itself involves so many studies, so many clearances, and no shortcut is allowed. Everything has to be perfectly done, and regulator has to clear that the site is safe. Then only you can start the construction of nuclear power plant. Then during construction also stage-wise clearances are there. Of course, in case of BSR, since design is frozen, so I will guarantee you that from regulator, there will not be delay of even 1 day. In case of, I have seen design is frozen, they give clearance, blanket clearance. Only thing is that this quality aspects, there are quality checks, stage by quality checks that will happen. So this private sector they have to learn this process. That every stage they have to wait for quality clearance, and that waiting period can be reduced to a single day. It can be cleared on the same day. So that type of practice has to be evolve, and they have been following, but they have to follow in a rigorous way and thinking that there will not be any shortcut, and that way they can proceed further. As far as plant operation is concerned, that involves a lot of training program, so they have to undergo a lot of training program. Qualified persons have to be inducted, they have to be trained, then only they will be licensed, then only they will be allowed to operate the plant. So all these processes have to be followed. So after constructing and operating one BSR, perhaps they will be totally mature to take up any type of nuclear power plant construction or operation.
Okay, thank you, Mr. Sharan. I think with that we are probably running out of time for this panel, but if I could summarize, I think there is a big opportunity certainly available in India for the nuclear energy generation to find its sort of place in the sun in the energy basket. Certainly we have the capability, and if the right regulatory and policy package and framework and proposals are put in place, I think that will go a long way in the nuclear sector doing better than what it is doing. Then there is certainly a need for private participation, private sector participation in the sector in order for the potential to be realized. But of course, with I think the right kind of hand-holding and I think conscious familiarity with safety protocol. And with that, I think, of course, I would like to thank all the panelists. I think the panel certainly, according to me, has lived up to the billing that I was thinking that it would. And thank you, Mr. Sharan. Thank you, Mr. Mitra. Thank you, Professor Srikanth, for joining me on the dais and sharing your